Okay, let's look at completing the square today. We just finished dealing with perfect square, and I want to believe you understood that aspect of perfect square. If you did not, then you need to replay that class, get a better understanding for you to be able to deal with completing the square, because I said completing the square is simply an extension of perfect square. So we want to apply perfect square here and extend the solving to get the final result. Remember, in our perfect square, the first step is divide through by the coefficient of the first variable. So we want to complete this square, want to solve this problem using completing a square, or want to find the value of x. We want to make x the subject of this relation, of this formula, using completing the square method. So carefully pay attention to what we are going to be having today. Solution. Remember, your first step is that you should divide through by the coefficient of the first variable. So I'll do that. Divide by A, divide by A, divide by A. A will cancel A. I'll be left with x raised to power 2 plus B over AX plus C over A is equal to 0. Now, the next step is that we should find the half of the second variable. Find the half of the second variable, which is Bx. In this case, it's B over AX or BX over A. We have to find the half of BX over A, which is the second variable. We'll be having that x squared plus 1 over 2 times B over AX plus C over A is equal to 0. That will lead us to the next expression, which is x squared plus B over 2A x. 1 times B is B, 2 times A is 2A. 1 times B times X is Bx. That's what we have there. Plus C over A is equal to 0. That's what we have now. The next step from our perfect square idea is to open up the difference of two squared brackets. Here we have that. Is plus C over A is equal to 0. Remember, we are only perfecting the squares now from this part. This is a constant value. Don't forget. So we're going to have it done this way. The first bracket will have the variable x plus the coefficient of the second variable, which is b over 2a. And the other bracket we have only the coefficient of the second variable, which is b over 2a. All squared plus c over a, which is the c over a we had from the very beginning, is still here, is equal to 0. Now, we're going to extend the solving now. And that will take us to this other level where we have x plus b over 2a all squared minus b over 2a all squared plus c over a is equal to 0. If we work on this, we're going to have x plus b over 2a all squared minus b over 2a times b over 2a. That is b over 2a times b over 2a plus c over a is equal to 0. If you multiply these two factors here, we'll be having x plus b over 2a all squared minus b times b is b squared over 2 times 2 is 4, and a times a is a squared. So 2a times 2a is 4a squared plus c over a. Remember, we have to make x the subject of the relation. From the start, I said so. So we need to take all the values that have no x attached to them to the other part of the equation. So minus b squared over 4a squared will be leaving to the other side, and plus c over a will also leave to the other side. We'll be having this x plus b over 2a all squared is equal to minus b squared over 4a squared becomes plus b squared over 4a squared at the other side of the equation, and plus c over a becomes minus c over a at the other side of the equation. These are two simple fractions, so we need to find the LCM of 4a squared and a. The LCM is still 4a squared. 4a squared into 4a squared is 1. 1 times b squared is b squared minus a into 4a squared is 4a, and 4a times c will give us 4ac. So we have the new expression as x plus b over 2a all squared is equal to b squared minus 4ac all over 4a squared. This will lead us to another expression. We want to make x the subject, so power 2 must leave to the other part, and that becomes the square root of the other part. So we'll be having x plus b over 2a is equal to the square root plus or minus the square root of b squared minus 4ac all over 4a squared. Now, this is a solving problem. It's a solve. We can express it in two forms, but don't forget, the down number here has a perfect root. It was 2a times 2a that we multiply, gave us 4a squared. So if we find the square root of 4a squared, your answer will still be 2a. So that will be x plus b over 2a is equal to plus or minus root b squared minus 4ac all over 2a. Why? Because the square root of 4a squared is 2a. So we want to make x the subject finally. For us to make x the subject finally, plus b over 2a will leave also to the other side so that only x can be standing now. So we're going to have that as x is equal to plus b over 2a leaving, it becomes minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. These are two different fractions having the same denominators. It will be better for us to write it in this form. X is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. This formula is known as general quadratic formula, but some people call it the almighty formula. I did not see that to be any almighty anyway, but it's actually called the general quadratic formula. It could only be almighty if it is used to solve all mathematical problems, but it only helps to solve quadratic problems. So this is the general quadratic formula, which is x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. In our next other class, we shall be solving using this formula, but we need to have a better understanding of completing the square in our next other class before we can use the formula. So see you in our next other class.